Welcome back to the second chapter of our exploration of Gradle. Here we're going to do a full build and get our application deployed to Tomcat. Although you can write tasks in Gradle, just like we did in the previous chapter, for building, Gradle can do most of the hard work via plugins. So Gradle is a bit like Maven in this respect. With a few lines of Groovy, we'll be able to use the Java plugin to compile all of our code. And when we want to deploy a WAR file, again another plugin will do that for us. As with the Maven build, the WAR file won't be quite complete, so we'll have to move a few files around. And also as with Maven, because the jar files are stored in a hidden repository, if we want the code to compile under Eclipse, we're going to need to somehow update our Eclipse build path, and we'll see how to do that. Well, you might be imagining that, oh no, we're going to have to start listing lots of tasks and worrying about dependencies between them. But no. In this regard, Gradle is a lot like Maven, in that Gradle is able to do typical builds without needing any configuration. The way it does it is slightly different to Maven. Let's see how. We'll delete all of these tasks that we built before. And what we can do is we can add a single line at the top called apply plugin, followed by, well, for the moment this is just the word Java, but I'll show you where we can find a list of these plugins. Now a plugin in Gradle is, I guess, kind of similar to a plugin in Maven. Now plugin in Gradle is a collection of pre-built tasks. So effectively, just by adding this single line, you can imagine now in your mind's eye that we now have lots of tasks added automatically to our script. We don't have to write them, and they will have a good sequencing as well. And if you go back to the reference manual, you'll find it quite a way down in the contents list. At the time of recording, chapter 21 is called Gradle plugins. And then they have a list of all of the available plugins. On chapter 23 is details of the Java plugin. Now they're showing you here how to apply the plugin. Well, actually, I didn't use the quote marks. I think you need the quote marks, so I'll just add those in now. The main thing about a plugin, it's going to add some tasks. And here on the next section is a list of all the tasks that will be added as a result of applying this plugin. So all we have to do really is to find from the list of tasks the task that we want to execute and then make that our default task in the build. So the first task in the list is called compile Java. So we would just make that the default task, and there you have it. That's our build script. Now, of course, we are going to have to add a few things to that, but that really is it. If we now rerun the build, it's going to take longer to run this time because it is downloading some dependencies. And the default configuration of Gradle is that it doesn't tell you when it's downloading things. That's a bit different to Maven. But you know why the build has failed. It's for exactly the same reason as when we used Maven. We have a lot of classes that we're using, for example, model and view. That's coming from a third-party library, in this case it's Spring MVC, and we need some way of bringing those dependencies into our project. Now the great thing about dependencies in Gradle is that it works exactly the same as in Maven. It's just that the syntax is slightly different, but it does work with existing Maven repositories. One slightly annoying thing is that we do have to tell Gradle what the repositories we're using are. Now we didn't need to do that in Maven because there's a default hard-coded into Maven. That's the Maven Central repository. We didn't need to add further repositories in Maven, but you can do so. In Gradle, we do need to add a little block of code right here, which is a declaration of the repositories that we want to use. Now for this course, we're just going to work with Maven Central. Now what they've done here is they've provided a method that we can call, which is kind of just a shortcut, shorthand way of referencing the Maven central repository. To be honest, this block of code is pretty much cut and paste code. Moving to the interesting part, this is how we define the dependencies in Gradle. It's not using XML, but it's the same idea as in Maven. So the syntax looks like this. We have dependencies followed by a curly bracket, and then I'm specifying that we have a compile time dependency on the following artifact. And it's the same as in Maven. We have a group. We have, well, they call the artifact ID the name. I guess they've gone for name just because it sounds a little bit less pompous than artifact ID. And we also have the version. I'll show you in a short while that there is a more compact syntax for this, but it's a good way of starting so that you understand the concept of what's happening. So the group, name and version here are exactly the same as we had in our Maven build in the Maven part of the course. And of course, I've looked that up using the MVN repository. Let's get this into our build and see if it makes a difference. I will type this in longhand, but of course you can forward wind through this bit if you find it boring, but do make sure you do the same in your project. So we're declaring that we have repositories, but we're only using the regular Maven central repository. And then we're going to specify our dependencies. And we're beginning with a compile time dependency for which the group is org.springframework. And of course, I'm getting that from the MVN repository. So there's the group ID. And I'll copy the artifact ID. And that goes in as the name. Notice there's commas at the end of each of these lines because this is effectively a single line I'm adding here. And then the version for us is going to be 3.1.1.release. And that's our first dependency defined. Let's see if that made a difference. Again, you may find this a little slow because it will be in the background downloading the appropriate jar files. And here we go. And if you look now at the errors, we have 40 errors, which I didn't notice how many errors before, but you can clearly see at a glance there are now no Spring MVC errors, but all the errors are relating to other third-party libraries. So we'll have a look at adding those in a moment, but there is a much easier way of adding this dependency. You don't have to specify the group, name and version all on separate lines. In fact, there is a shorthand notation which goes something like this. We just have the word compile followed by a string which contains the group ID, then a colon, and then the artifact ID, and then another colon and the version number. Just like that. And then you can lose the other two lines and you don't need the comma at the end of the line. So I can run that to check that it works. And yes, it's still failing to compile with 40 errors. Now, if you look on the MVN repository page, you may have noticed there is actually a tab here for Gradle. And if I'd have clicked on that in the first place, you would have seen that that just removes that annoying step of having to build the string for yourself. So we now just need to go ahead and add in all of the other dependencies just like we did in the Maven part of the course. So I don't know if you remember, but this PDFP table comes from a third-party library capable of generating PDF documents called iText. So we could look in the MVN repository for iText. It's the first link you can see. And the version we need, I know I mentioned this in the previous part of the course, but it does need to be one of the version 2 options. So I'm going for version 2.1.7. We just need to click on the Gradle tab, select the string you can see there, and then back into our script, we would add that in as a compile time dependency. And it is easy as that. So we had 40 errors before. I have a build problem. And as you can see there, I've used 2 quote marks. And that happened because I was rushing. I'll slow down a little bit, just remove that quote mark, and we'll try again. So we had 40 errors before, and we're now down to 32 errors. So it's now just a case of completing these dependencies, which, as I mentioned when we had to do this in Maven, it's very tedious only because normally you would do this as you go along. So the dependencies that you need for this project are exactly the same as the dependencies you needed back in the Maven part of the course. So rather than hunting through all of those in tedious detail, I'm just throwing up here a caption showing you the compile time and runtime dependencies that you will need. Just to run through them, just to recap, we're using JUnit for testing, we're using the Spring MVC framework, but we also need the standard Java validation APIs and the Hibernate validator extension, because we're referring to that in our compile time code. Spring does reference it as well, but they're not transitive dependencies. We're using the Servlet API. You've seen this iText dependency, and we're using the Apache POI project to generate Excel spreadsheets. There are two dependencies we'll need at runtime when we eventually deploy our WAR file to the server, and that's a framework called Spring Webflow, and finally the standard Java JSTL. So you can pause the video now and get these dependencies into your build script, or of course you can always look at the sample code in the Practicals and Code folder, and you can copy and paste from there if you find typing boring. So I've added those dependencies now just off camera, and of course you can pause the video and get these dependencies in for yourself. But now if I run the build, of course we're going to see some more downloads now. As with Maven, sometimes these downloads may fail. The best thing to do is to retry a moment or two later, and failing that, try again an hour later or so. And well, I appear to have a successful build. There is one warning being output here, but that's the warning you may have seen earlier on in this project. It's just the compiler warning is that there are a few compiler warnings being generated. So we've got our compile working, but of course, another important step in the build is to run the unit tests. So we'll go back to the Java plugin information in the reference manual, and we're interested in the list of tasks. So we've run compile Java, but of course you can hunt through the rest of the tasks, and it looks like there is a test task, exactly what we need. And it's telling us that this task depends on compile and compile test. So it looks like we don't have to worry about the dependencies. We don't have to worry about invoking compile ourselves. We can simply invoke the test as a default task. So we'll change our default to test and rerun the build. And while we have a build successful, it's run more tasks this time because more tasks are needed. It has to compile the test code as well as compiling the regular code. Now, if you have a look in your project directory, there is a slight confusion here because we originally had this as a Maven project. And the one difference in the conventions is that Gradle is outputting to this folder called build, but Maven is outputting to the folder called target. I'll show you at the end of this course how to get rid of that target directory if you don't want it anymore. It is rather annoying. But it's just as a result of the way we've done things here by moving from Maven across to Gradle. The folder we're interested in is the build directory. And of course, inside there, you're going to find a classes directory where our compiled code is, but we're also going to find a reports directory. If you have a look inside there, we have a tests folder and the expected HTML file. If you open up the index.html, you get actually a different format to the default format in Maven and Ant, but it's the same kind of thing. 100% successful, wahey, and we can drill into the details of the tests by following the links. If we want to generate the documentation for this project as well, we'll need to look carefully here. We can see there is a task called javadoc, but its dependency is just the compile dependency. So in other words, if we were just to run the javadoc task, we won't get the test task running. So this is one of those cases where we're going to have multiple tasks on our default list. And we can do these in any order. So we'll do tests first, and then we'll follow up with the javadoc task. Now I've mentioned this before, but it bears repeating. The test task and the Javadoc task depended upon a compile running first. But that doesn't mean Gradle had to run compiles twice. It knew that a successful compile had already been run. So we should now find, if we go back into the build directory, there's now a folder called docs. And inside there, of course, we now find our Javadocs. We can go in through the index. And so this is our old friend, the Javadocs for this project, as we had in our Maven and Ant builds. Just a final word on the tasks in the Java plugin. I'd like you to notice that in a similar way to Maven, the clean task isn't a dependency of any of the other tasks. And so if you to do a project clean, then you will have to manually invoke that task. So I recommend that you add clean to the beginning of your default tasks. And of course, that means that the build directory will be wiped out at the start of the build, which means you're always going to get a completely clean build. The downside is that will result in a slower build, but it is safer. Well, the ultimate goal, of course, is that we need to be able to generate a WAR file so that we can deploy this project to a web server, just as we did with the Ant and Maven parts of the course. So I'm going to go back in my browser to the reference manual contents. So we're towards the end of the contents here. There's the Java plugin details. There's a plugin for Groovy. There's a plugin for a language called Scala. But now here we are. There's a plugin for generating WAR files. So we just need to follow the usual steps. The first part of the documentation shows us how to apply this plugin. So we just need to copy that line there and add it to our build scripts. And you just have a collection of plugins at the top of your script. We still need the Java plugin because we need that to do the compiling and testing and so on. But we now have a plugin capable of generating WAR files. The WAR plugin is quite easy. It adds a single task called WAR, which depends on compile. So to do a full build, we could make our default tasks be clean, test, Javadoc, and then add WAR to the end. I'm going to speed up my builds a little bit just to make the video easier to record really. So I'm going to remove the test and Javadoc tasks. You can do the same if you want, it doesn't really matter. But by invoking clean and WAR, that should be enough now to run a full build. Remember, WAR depends on compile. Well, it built successfully and we can see the WAR task definitely executed. If we check in our build directory, remember not the target directory, but the build directory, the default location for WAR files is in this folder called libs. And if you look inside there, we have a WAR file, which by default has the name of our project. Well, it's good that we've got a WAR file, but the first thing, I don't like its name. It's inheriting the name of the project. Remember, the project name is just really the name of the parent folder of our entire project. Well, it's a little bit out of date for a start because it's still called Maven Projects. Now that's a bit annoying. I'd like to somehow rename this WAR file once the build is complete. And the thing about Gradle is because we've got a very powerful programming language here, there are an endless number of ways that we can do this. We could even write some code here at the bottom of the script to go straight to the file system and to rename that file. Now that's certainly possible to do, but it sounds a little bit heavyweight to me. Now, of course, I could go and Google and see if I can find an answer. Certainly a good approach if you're stuck on a project. But I'd rather find out a way of doing this using the reference manual. And this is where I have a bit of a problem with Gradle, because if we look in the WAR plugin at chapter 26, it's telling us the default task is WAR, so we know about that. The project layout here is just telling us where to store our web application files. Well, we've already done that. We have a folder called src main. And if we go a little further down here, there's convention properties. Now, these are properties that we can override when the WAR plugin runs. But disappointingly, it's telling us the web app directory name and a web app directory. Well, these are related to directories. that's not what we want. We're trying to rename the war file. And actually, if you go all the way down, although they give some examples down here on how to use the plugin, there's no reference to the name of the resulting war file. And I don't understand the structure of this document really, because you're going to find the answer on this link here called DSL reference. Now, I'll digress a little. The DSL stands for Domain Specific Language. And that's quite a buzz term in software development at the moment. A DSL is where a language has been taken, like Groovy, and it's been twisted and it's been altered to feel like a different language, but a language that's very specific to the problem that we're trying to solve. The build script you can see here is a DSL. It's Gradle's DSL. They've made the Groovy code look more specific to the job in hand. And you're going to find in this DSL reference, if we look on the left-hand side down here, there is a list of tasks. And if you find the war task, rather helpfully, you'll find that there's a collection of properties. So this is kind of the internal data the task is using. And it turns out that we can override any of these properties. And there's quite a long list of them, but one of them is very simply the archive name. Well, that appears to be what we're looking for. And it's actually really easy to override that archive name. Let me show you in the script. All we have to do, and it's rather similar to Maven really, in that we have a plugin here, but we'd like to override one of the plugin's defaults. In this case, it's the war task. So we just refer to the task, we add in curly brackets, and then we can override any of the properties that we want to. So I want to take the archive name, I want to give it a different name, and our name is going to be, let's say this is our Gradle web app.war. Similar to what I was referring to before, where when we refer to a task like this, we can add extra jobs to that task, or we can change any of its properties. So let's run that, and be careful if you have opened up the build directory in your Explorer, you will want to get out of that folder because it won't be able to delete the folder when you try to clean it. Well, it didn't crash. And if we now check in the build folder, in the libs directory, wonderful, we now have a war file called Gradle web app. So the thing to take away from that is every one of these tasks has a set of default properties, but those properties for some reason are buried away in this DSL reference, or at least they were at the time of recording. That might have changed by the time you watch this, but the point is that somewhere in the reference manual there will be a list of properties that you can override. The final job of the build is to deploy our war file to Tomcat. Now again, I'm assuming that you already know how this works because you will have done the Maven Ant parts of the course. What we need to do is we need to copy the war file from our project into the Tomcat web apps folder. So I'm going to call the task deploy to Tomcat. But this is a little bit different to what we've seen before, and it will introduce some groovy syntax. It's a little bit beyond the scope of the course, but I hope you get the idea of what's happening. Already built into Gradle is a pre-built task called copy. We can take that existing task and we can turn it into a task of our own. The way it works is what's inside the round brackets here, type copy. It's kind of the equivalent of Java inheritance in that we're saying that our deploy to Tomcat task is going to inherit from the existing built-in copy task. And all we're going to do is we're going to override the inherited properties. So this is a very neat way of writing our own tasks that are based on existing tasks. Now I'm just working from the reference manual again here, and it turns out there are two properties I need to override. It's very simple. There's the from property, which is saying the file I want to copy, followed by into, which is of course the destination directory. Now we'll need to think about where the Tomcat folder is, but we'll do that by writing this into our script. So then, this is a new task that we're defining here, and I usually put my tasks before the dependencies. So this is a new task called deploy to Tomcat, And as I mentioned, it's based on an existing type of task called copy. It's capital C on the copy, by the way. And in here, I'm going to specify that we're copying from the build directory. And all of these directories are relative to our project roots. So I can just go straight into build. I could have said /. It's up to you. So it's the build libs directory. Just to check in Explorer. Yep. And we're looking for the file called gradlewebapp.war. Careful to type that correctly. gradlewebapp.war. Well, actually, I can tell you there is a little bit of a shortcut here. You can use this, but if you prefer, you can just say from war. Now, I realize that looks a little bit magic. War's a kind of inherited variable from the previous war task. I think I'm going to go for the longhand form just because it's a bit more obvious what's going on. And we're copying into the Tomcat folder. Now, you'll know from previous chapters that this folder is one level up from the project roots, and then in a folder called Tomcat, and we're aiming for the web apps folder. Now, we'll need to think about how to invoke this task. There are several ways you could do this. We could add it to the end here. We could add deploy to Tomcat right here, or if you prefer, we could remove the war and we could make war be a dependency here. So we could say that deploy to Tomcat depends on the war task running first. Now that's up to you which approach you prefer. Now before I run the build, I'm going to need to start Tomcat, and the process to do so, of course, is exactly the same as on the previous chapters of the course. So if you're confused here, do check out the chapters on either building Maven web apps or building Ant web apps. I'm in my workspace folder here, and I just need to run the start.tomcat.bat file. Now, in the previous chapter, we deployed the Maven version of this web application, which is the application that's currently starting up right now. That appears to have started up okay. But just to keep things clean, I'm going to the Tomcat folder, into web apps, and I'm going to delete the my Maven web app.war file from before. That will, after a few seconds at least, cause Tomcat to do some stuff. It's actually undeploying the my Maven web app. And if I go back into this web apps folder, you can see now that the Maven version of the web app is now gone. So back into Eclipse then, and we will rerun our Gradle build. Well, the deploy to Tomcat task has now run, and there were no errors reported. And I will check the Tomcat console in a minute, but the thing you're looking for is if you go into your Tomcat web apps directory, you are expecting to see now gradlewebapp.war. If that's not the case, then check your script very carefully. If you have any typos, you probably won't get an error, but it will just silently not copy the file across. After a few seconds, Tomcat will try to deploy this application, and it will create a corresponding folder called Gradle Web App. Well, going back to the Tomcat console, we have an exception, but this is the same exception that we had on both the Ant and Maven parts of the course. This is simply happening because there's a file not found exception. In the war file, we're missing a file called application.xml. Just to remind you, in the project structure, in our main source, we have a file called application.xml. We need that to be in the webinf directory of our war file. So we could, as a quick fix, we could drag that file from resources into the src main web app folder, and there's the webinf directory. So if I just copy that across now, you don't have to do this because I'm going to give you a better suggestion. If I copy that across and rerun the build, now this XML file will be visible to the web application. Okay, back to the Tomcat window. You will need to wait a few seconds as usual. And this time the output looks very different. There's a lot of logging here coming from Spring. It is saying that it has now deployed. Now, there's a bit of a problem with that. As I mentioned in the Maven part of the course, that's a real hack because now, although the war file is working, this project would no longer run as a standalone console application because the application.xml file isn't in our source tree anymore. So there's a few ways that we could handle this. If I move that back to where it was, you might think one way of handling this is to add a task into here to copy that file into the web app webinf directory at the start of the build. I don't think that's a very good idea because that's copying it into our source tree, and therefore it will be left hanging around even after the build is completed. And then an engineer wanting to modify that file won't know which version of the file to work on. So that's not a great idea really. But again, you can use the reference manual to work out if it's possible to configure the plugin. I've gone back here to the user guide. I'm not on DSL reference anymore. Here's the user guide. Back at the War plugin, you'll find that many of the plugins have a section called customizing. And if we go down to here, this is where they're configuring the WAR file. They're showing you how you can add additional files into the WAR file. And the one we want, this line here, enables us to add a file set of files in other words, into the webinf directory. Now that's exactly what we need. So we just need to specify webinf and then in the curly brackets from followed by, and it looks like just a directory or maybe a single file. So we'll do exactly that. We just need to add this into the war task definition. So as in the reference manual, we're specifying that we want to add extra files to the webinf, and that file set is going to be in curly brackets, and we're working from the src main resources folder, in particular the file called application.xml, and that's all in single quotes. But I could have specified a folder and that would have copied the whole folder across. And it looks like it's going to be as simple as that. So let's rerun the build, possibly for the last time. Okay, so we're compiling and there's the deploy. And I'll switch quickly across to the Tomcat console. This was a previous deployment, so within a few seconds, yeah, it's ticking over now. And again, lovely clean output, but we've preserved the possibility to run this app as a standalone console app. Well, we need to test this out back in a browser exactly as we did in previous chapters. It's going to be localhost :8080. This time around, it's called Gradle web app. Of course, be careful to spell that correctly. And the front page is viewallbooks.do. And I can't tell you how relieved I am to see that output. We did a technical review of the Maven part of the course and someone complained that we worked really hard to put the Excel and PDF generation dependencies in and we never saw them in action. So just in case you're that bothered about it, I can tell you that if you visit viewallbookspdf.do, PDF in capitals, that should generate a PDF document. That's proving that the PDF dependency is working. And similarly, we can visit viewallbooksexcel.do, and that's downloading as an Excel spreadsheet if you happen to have Excel or OpenOffice installed. Well, I'm not really bothered about that. The point is that the Gradle build was successful. And the thing I want you to take away from this really is that you can see how small this configuration file is. It's smaller than the Maven POM, but much smaller than a comparable Ant build would have been. And of course, as I've mentioned many times, we've got the potential to put any code we like in here as well. And there's one last job I want to do with this build before we finish, and that is to make sure that the build is correctly working in Eclipse as well. Now you might have noticed that since we started this chapter, there have been no compile errors in Eclipse. If, for example, I go into, well, you can pick any of the Java files. I go into the springclient.java file. Everything's compiling inside Eclipse, but actually that's because we configured the build path for this project back in an earlier chapter when we were still working on Maven. Oh, but I should remember that some of you will have come straight to this chapter without doing Maven first, in which case I guess you will have been seeing a lot of compile errors inside Eclipse. Hopefully, though, not in your Gradle build. If you right-click on your project and select Build Path and select Configure Build Path and click on Libraries, there's a lot of references there to the Maven 2 repository. It's only really an accident that we're seeing a successful compile in Eclipse. If, of course, you just started this project cold, then none of these would have been referenced. So I've just highlighted them all, and I'm going to click on Remove and click OK. So this is more like a project that you've just started from scratch would see. We've got like 154 errors because, of course, it's not finding any of the dependent jar files. Just in case you're interested, the jar files for Gradle are being downloaded into your user's home directory in a hidden folder called Gradle. You may or may not see this folder depending on your environment settings. And it's got slightly complicated structure in here, but if you look inside caches, and then there'll be a folder called Artifacts, and inside their file store, eventually you get to the, for example, Spring Framework dependencies. And there's WebMVC. I've got a couple of releases in there. Finally get to the jar file. So that's intended to be a hidden directory. You're not really supposed to be working inside there. But of course, we've got to get a link from this project to that folder. And the procedure is pretty much the same as it is in Maven. There's a plugin, and you'll find details of it again in the reference manual, called the Eclipse plugin. And as usual, you'll be applying it. So I'll just copy this and get that into my build script. And it has several tasks, but the important task is this Eclipse task right here. And that will generate Eclipse configuration files. So I'm temporarily going to add Eclipse to the front of my default tasks. Now, before I run this build, it's going to rebuild all the details of the Java build path. Let's right-click on the project and select Build Path and Configure Build Path. This plugin is going to add all these source folders again. It's going to add in the system library again, and it's going to add in all of our required jar files. And certainly with this version of Gradle, that does cause a bit of an annoying problem in that you end up then with duplicates of everything. So if you can just follow along with me, just remove all of the source folders that you can see on the source tab, and then under libraries, don't worry, it will be replaced, remove the JRE system library. While you're here, you might also want to, for default output folder, click on Browse and find the build directory and click through to classes and then click on OK. Now, it's telling me that the output folder's changed. Do we want to remove that? We can say yes to that. That's the folder that Eclipse was generating. And now we're getting no compile errors purely because it's not finding any source code to compile. So that's not really a good thing. And just as a last step, just to clean things up, I'm going to delete the target directory. Remember, that's the directory generated by Maven, which we're not using on this chapter. I couldn't delete that earlier because Eclipse had a reference to it, and Eclipse would have just simply rebuilt that every time we deleted it. So that's a bit drastic, but if I now run Gradle, this Eclipse task should regenerate all of that correctly. Okay, the build ran through okay, and it's certainly done something with Eclipse. Now, if I right-click on the project and select Refresh, you can see there's a big difference now. It seems to have rebuilt the folder structure. And if we go to the Problems tab, we're now getting warnings, which is good. That means the compiler's running. Just to really test this is okay, I'll just find a class. Any class will do. And I'm going to make a compile error. Any compile error will do. Yeah, that's definitely working. The compiler's back on its feet okay. So if you're interested, you can look in the build path on Configure Build Path, and you can see it's added the source folders. It's added libraries, including the JDK. And if you're really interested, you can pick a random jar file and you can look at exactly where it's located. It's inside that Gradle cache. So that was a little bit sticky, but that was really only caused by the fact that we've taken an existing Maven project and we've sort of mangled it around a little bit. We did have to give Eclipse a little bit of a poke to make it refresh itself. You would have to be careful to rerun this Eclipse task every time you add in a new dependency, and it's up to you as to whether you leave it on the default task list. We've reached the goal. An application successfully deployed to Tomcat. And Gradle has really combined the power of Ant and Maven. If you want to do low-level scripting, you can do that by writing your own tasks, and the whole of the Groovy and Java language is there for you. But for high-level jobs, plugins work just like their Maven counterparts. We added the Java plugin, and that introduced a set of sort of hidden tasks to our script. There's no life cycle in Gradle like there is in Maven. Instead, the tasks use Ant-style dependencies. I hope you're now comfortable with using that manual to look up the other plugins. We did the War plugin, and the only real problem was finding out about its properties from the DSL reference. Of course, as we're also developing in Eclipse, we want the code to compile inside Eclipse as well so that we don't get red lines everywhere. And I hope you've been able to get that working. So that's it for Gradle. All that remains is the summary chapter, and the main thing I'll do there is close down the course, and I'll also show you the 3 builds running on the command line.